So we are going straight to be looking at concept of mechanical energy. You know, what comes to your mind when you hear mechanical energy? When you say mechanical energy, actually we think of machines. Am I communicating? So when you say the concept of mechanical energy, you know, these mechanical energies are said to be the energies that of an object, of a body, as you know, as a virtue of their condition or motion, as virtue of their state or condition, state or condition or motion. Are you with me? So if an object is moving from point A here to point B to a particular height, the amount of work you did by moving a particular mass of an object, if the object has a mass m, moving it from here to a certain height, you are moving, you know, you cover this height from here, you cover the height from here to here. This height you covered. Am I communicating? The work done in moving this mass, okay, from point A, the ground state, to point B at a particular height, am I communicating, is actually equal to work done, of course, is equals to the product of the force you apply in moving it times the height. Are you with me? But normally, since you are moving against gravity, you found out that your force, the force you applied here, is actually equal to the mass times g, which is acceleration due to gravity, because you are moving against gravity, or you are moving under gravity. Am I communicating? Of course, you're not moving for gravity. You're moving the object, you know, this object, you know, let me say this is a ball. You move it from point A to point B. The force you applied in moving it from A to B is mg. Am I communicating? Then automatically, the work done is actually equal to force, which is what? Mg times what? H, which is mgh. Are you with me? So, which means when we talk about, you know, energy, for this is known as potential energy, because it is as a result of the condition of this object. The object is not moving linearly from one point to another with a particular velocity. No, you just moved it with your hands, you know, or with a particular force from one point to another on that same position. But the position of this, you know, the position of the object here is not just because it's at rest here, okay, because I'm using this to explain for now. So it's not just because it's at rest here, because even if it is at rest, the energy of this ball is still mgh. But the point I'm trying to create here is that since I am moving this from point A to point B, that is from down to up, what I just did is I just changed the state from from down to up. That's what I did. I moved from up to down. So the amount of energy I spent in moving it from here to here is equal to the amount of work I've already done, or the work done, right? So which means, and from the calculation, you find out that the work done is equal to mgh, and automatically this is also equals to what? Potential energy. Am I communicating? The object is not moving with a particular speed per se. You just moved it from here to here. All right. Am I communicating? So you move it from here to here. So the potential energy of the object, which is the work done, is known as what? You know, mgh. Are you with me? So as a virtue of state or condition, or you can say as a virtue of change in configuration, potential energy is an example or one of the types of mechanical energy. Are you with me? So when we look at mechanical energy, like I said, mechanical energy is divided into two. All right, mechanical energy is divided into two. So in this part, I'm going to be explaining mechanical energy more better for you. So mechanical energy is divided into Number one is potential energy, then number two is kinetic energy. So we have potential energy, and we have kinetic energy. So potential energy is said to be the energy of an object or possessed by an object which is at rest, or the energy possessed by an object based on its position or condition. So here I have at rest, at position, or condition. The under condition, we can have change in configuration, which I already explained them earlier on. Then here is typically energy possessed by an object under motion. Under motion. So this kind of energy is as a virtue, or comes, or comes through the movement of a particle or of a body or of an object, okay, with a particular velocity. All right. So another way you can, in exam, another way they can ask you question under potential and kinetic energy is that sometimes they will be like, which of the following energy, mechanical energy, is said to be the energy which causes an object which resists an object from undergoing motion. I get to my point. The answer should be about potential energy, because potential energy is the energy possessed by an object, all right, for it to be at rest. When it is at rest, then kinetic energy is what is the minimum energy required to cause an object which is at rest, which is already at a particular position, all right, to cause it to move from that position to another. Do you see that? So here I have potential energy PE. So potential energy PE is given as what? mgh, which is equal to work done. So the work done in moving an object, from point A, from the ground to a particular height, h, is known as what? Potential energy, which I already explained earlier on. So, and again, potential energy has many types, but typically the potential energy is just into three. We have three types of potential energy. Number one type of potential energy is gravitational potential energy, which is the one I showed you. I've already explained it, okay? When you're moving an object from point A to point B under gravitation, which is a constant, okay, and the height h, then you're moving a mass body. This is a mass, okay. Of course, if I put downward sign, it actually means weight, but I'm just trying to conserve the board. So this is the mass, okay, moving it from here to this particular point, okay. You are going to spend potential energy. So, and what that's supposed to mean, since you move this ball from point A to point B, at this point the ball is now possessing an energy. That's why if the ball falls now, once it hits any object, it can cause distortion, or it can cause movement of the object it falls on. Am I communicating? Because you have already given it potential energy. So on falling, you'll find out that what? That potential energy will become equal to kinetic energy. So the potential energy is now converted into kinetic energy. I will explain more about this when I'm going to be doing applications of mechanical energy in our daily lives. So, but like I said, we have gravitational potential energy. Number two, we have electrostatic potential energy, and number three, we have we have stretched, stretched, compressed, potential energy. So these are the three major potential energy we have in physics. All right, the gravitational potential energy, the electrostatic potential energy, and the stretch compressed potential energy. All right, so when you have charges which you actually produce by, probably, let me give an example, using the brush of your pen, you rub it on your, you rub it through by frictional force, okay, rubbing it on your hair like this. Maybe after rubbing it, you found out that when you touch or bring it closer to a paper, you found out that it will possess a particular or a certain amount of energy. That is what electrostatic potential energy. It is electrostatic simply because that charges that you produce there, that energy cannot be transferred from this point to another point, unlike what we have in dynamic electricity. All right, so that's by the way. Then I have stretch compressed potential energy. When you have a spring, okay, if you draw a spring, as you're drawing it, you are already, that what we call changing the configuration. As you're drawing it, you're already applying or inducing potential energy in that spring. So once you leave it, you'll find out that anything that the spring carries can actually cause, can actually cause to move, actually cause to be converted into kinetic energy. So the potential energy of a compressed stretch spring, stretched compressed spring, am I communicating, is actually an example, another type of potential energy. And that's what we use in that guns. In that guns, you found out that there is spring inside it. So you can, if you put an object like this in the spring, if you put an object like this inside the spring, for instance, and you cock the gun. So inside the spring, I have something like this, which will look like a pistol or a bullet, as case may be. This is a material. Okay. So if I compress it, okay, as I'm compressing it, I am adding potential energy to the spring. So once I releases it, am I communicating? This spring that is become stretched now, right? So the spring, on being stretched, on going back to normalcy, you found out that taking its original shape, you found out that it will push this material to come outside with a speed. Am I communicating? So converting the potential energy into kinetic energy. So with this, the gun can move and shoot on what is being targeted to shoot. Right with me? So that is what we have in potential energy. So potential energy, like I said, has a formula. PE is equals to mgh, where m is the mass of the object or the body in question. Then g is associated to gravity, which is a constant, which is approximately 10 meter per second squared. Then height is the distance, is the distance of the object, or the distance moved by the object. Are you with me? So let's look into, believe I'm not forgetting anything, I'm not skipping anything on that potential energy. So let's move into kinetic energy. So under kinetic energy, this is the energy possessed by an object by the virtue of its motion. When an object is moving, do you understand? You find out that it carries a particular, energy. So that energy possessed by an object due to movement, due to motion of itself, is known as what? Kinetic energy. So when you say kinetic energy, like I said, is the energy of an object or body by the virtue of its motion or movement. Are you with me? So kinetic energy is another type of mechanical energy. All right, so here